As we have seen that efficiency is ratio of output power and input power, and it shows the performance of the transformer. So based on this efficiency formula, let us try to check how we check the performance of the transformer with the help of numerical values given. So here we are given a transformer with 500 kVA rating. Voltage ratio is 600/400 volt. This means that the on primary side voltage is 600 volt, the secondary side voltage is 400 volt. It is a single phase transformer with 50 Hz frequency, and its primary and secondary resistances are given as R1 is equal to 0.4 ohm and R2 is equal to 0.0015 ohms. Okay. Next, we are given the iron losses, which is fixed throughout the performance, is 3.25 kilowatts. Next, what we are given is we have to calculate efficiency at full load. Okay. And second condition, we have to calculate the efficiency at half load with power factor of the load as 0.8 lagging. Okay. So this is the data given. So let us start with first, that is efficiency at full load. So as we have observed, our priority is we need to know current on primary or secondary from these two data given. Then we have to know the power factor which is already given. Then we will calculate copper losses and we'll be able to put all the values in the formula of efficiency. So first we have to calculate current. So as we are given here, this is actually 6000. So we are given here the voltage on secondary and primary. So here we can calculate the transformation ratio as V2 by V1, which would be 400 divided by 6000. So what would it be? 1 by 15. Okay. Now I2 would be full load kVA rating is 500 into 1000 would be 500,000 volt ampere divided by secondary voltage, that is 400 volt. So what we are getting is 1250 ampere as the secondary current flowing in the secondary winding. अब हमें निकालना है सेकेंडरी साइड रिफर्ड रेजिस्टेंस. क्यों? क्योंकि हमें कॉपर लॉसेस कैलकुलेट करने के लिए रेजिस्टेंस जरूरी है. तो चूंकि सेकेंडरी साइड का करंट निकाला है, हम सेकेंडरी साइड रिफर करते हुए रेजिस्टेंस निकाल लेंगे. दैट इज आर. इट कुड बी टेकन एज k square r1 plus r2. Here r2 is 0.0015, r1 is 0.4. K we have taken as 1 by 15. We already calculated it. So this will give you R1 plus R2, which gives secondary side referred resistance, which is coming out to, after calculation, what we get is 0.003278 ohms. अब हमारे पास एफिशिएंसी के लिए दो पैरामीटर्स तो हो गए. हमें अब निकालना है कॉपर लॉस एट फुल लोड. इट इज I2 square R2. This is referred value of resistance on secondary side. So this will give us total copper losses, primary as well as secondary. क्यों? यहाँ पर पूरा resistance हमारे पास है. तो it is 1250 whole square into 0.003278 ohms. So this is giving us copper losses in watts. It would be, after calculation, 5.122 kilowatts or 5122 watts. Okay, so now we are available with PI as well as P copper. अब हम एफिशिएंसी इजीली निकाल पाएंगे. तो एफिशिएंसी के लिए फॉर्मूला क्या है? एफिशिएंसी इज इक्वल टू आउटपुट पावर divided by output power plus both the losses, that is Pi plus P copper. Now put all the values. Output power is 500 is kVA. We have to convert into kilowatt. पर हमारे पास हमें पावर फैक्टर भी मिला है, तो हम इसको जब मल्टीप्लाई करेंगे 0.8 से, we get value in kilowatts, that is output power rating particularly. और उसके बाद चूंकि हमने सारे किलोवाट्स में ही वैल्यूज लेनी है, तो इसको हमें 1000 से मल्टीप्लाई करने की जरूरत नहीं है. तो नीचे भी 500 into 0.8 is 400. So we can write directly 400 plus iron losses, which is fixed, and copper losses 5.122. So here we can calculate efficiency, which will come out to be 400 by 408.372. और यदि हम इसको 100 से मल्टीप्लाई कर दें तो we will get it into percentage, which is 97.94%. So here we have got efficiency at full load. अभी हमें दूसरे पार्ट में निकालना है efficiency at half load. At half full load we have to see that output power के अंदर जो current है वो हाफ वैल्यू है, that is x is equal to half. सेकेंड पार्ट हमारा था efficiency, we have to calculate at half full load, right? So here we have to see that now current is reduced by 50% or just exactly half. तो अब efficiency के लिए हमारे पास फॉर्मूला में जो चेंज आता है, that would be x into vi cos phi, whether it is on primary side or secondary side. यहाँ हमने secondary side लिया है. और इसके अलावा डिनोमिनेटर में we take output power plus, as I said, pi will remain as it is, but the copper losses जहाँ पर I square term involved है, we have to take it as x square into p copper. बाकी हमारे पास सारे calculations रखे हुए हैं, so we have to just place the values. Half into 400 divided by half into 400 plus pi was 3.25 plus copper loss was 5.122 into 1 by x square, that is 1 by 2 whole square. So this will give us, after calculation, 200 into 200 divided by 204.53. So this is ratio, but we need to calculate into percentage. So multiply these quantities by 100, we get the efficiency at half the full load as 97.78%. So here you can easily check कि जो full load के near performance होती है, efficiency of transformer is higher compared to the half load by minor percentage, but that varies a lot with the higher rating of transformer.